go. Okay. All right, so we're recording somewhere. This is being recorded. All right. Yes. So this is fall of 2022. This is the first set of practice problems for test 2A. All right, so what I'm going to do here is I'm going to quickly sketch out what I would do on each of these. And these first ones are pretty, we've done this so many times in class. I'll make negative slopes blue, and I'll make positive slopes, as I've been doing lately, green. And so first you color in your right triangles, and I'm doing a sloppy job. I'll do a nicer job. And then you come down, I'll do a nicer job on the next page. And then you come down here and you figure out what the slopes are of each one of those. Like in the first case, for the first one, we're dropping 8, we're running 10, so negative 0.8. So you come across at negative 0.8. Put an open circle. Okay, I don't think we need to spend a whole lot of time on this because this is stuff we've done a lot of. All right. So I'm gonna go cut right to the chase and go to the answers. Unless you guys, anybody have a question on this? I should give you all a chance to chime in with a question if you have it. Thumbs up means you're ready for the answer. 1, 2, 3, 4, 5. Okay, here we go. So here's the answer. And hey, by the way, I bet my guess is we'll find some mistakes because I just did this while watching The Crown. So I'm sure I made a mistake here or there. Take a look at yours, look at mine. The red is the average velocity, okay? So both ways of showing it. I should do it this way. So from here, you start at the beginning, you end at the end here, and then it's the slope of that line, which I showed here to be about 0.2, negative 0.2, 1/5. Yes, 1/5. So negative 0.2. And so that's that red line that goes all the way across. Okay, questions. You can type your question or ask a question for this problem. Said, what is the 1B said, what is the mule's highest speed? Well, even though it's going negative, the highest speed is 2.4 miles per hour, pretty slow. And it's called a 1F, it's called a step function. Yeah. Okay, so nothing really new on that problem. Well, not much new in any of these problems. We've already gone over it all. All right. Can we move on now to the next one? Thumbs up. Okay, one person, yeah. Okay, good. Your silence tells me you're ready to go. The next one, then, doing the same thing. I just keep hitting, beating a dead horse here. Keep going, but it's important to understand these. So my negative slopes, I'm showing with the negative right triangles, positive slopes, positive right triangles, just finding the slopes, blah, blah, blah. And then I plot those, whatever those are. So I've done the work on this. I think this is all we can go on to this. Let's go to the answer just to make sure that I did it right and that you did it right. I'm into, for some reason, blue means negative and green means positive. Any mistakes that you see there? Looks right. Negative 2.70. You got to show that zero slope here. Oh, remember your open circles at the end of the segments. You don't need one on the last one. This is a lot better for you if you've done it already. Trying to quickly copy stuff down. There's no reason to do that either. You should wait and just do it when you can record it, when you can watch the recording and pause it. All right. Kathleen has her microphone on because she's going to ask a question. Looks like she sounds like she's eating something. She's eating cashews. Nope. Okay, turn the microphone off. All right, so if there's no questions on this one, once again, fairly obvious, let's keep moving. Number 3. Well, the plot thickens a little bit. Now we got to do some integral stuff. So let's get this. So once again, same idea. You know, do your, this time it's stalactites and stalagmites. So I got a couple of stalactites. And I'm doing a sloppy job. I do a much nicer job on the key. And there's sorry, those, the blue are stalactites. The green are stalagmites. Okay. And then all you do, you find the area of each one of those. I really think you ought to use this T-chart. This is all laid out for you, and that's kind of nice. So you don't have to use the T-chart, I suppose. But remember, it's accumulation of area. As I go left to right, it's accumulation of area. All right. So nothing really new there. But let's go to the stuff that is sort of new. We haven't done a whole lot of this, and that is the integral signs. So if you haven't done this and you're watching the recording, you should probably hit pause and try and do these integrals down here. We don't really need the top graph to do these integrals. Okay, so here we go. And the first one, I'm going negative. So I'm going from the 0 to 6 seconds. I picked 3 of these, 0 to 6 seconds. So I'd say 0 to 6. And as long as you put units on one of them, that's fine, 0 to 6 seconds. And then all I do is put my function in there, which is really simple right now. -3. I wonder, well, we're going to get to, in packet 2, maybe, and certainly packet 3, we're going to get to more complicated functions. Because what we did today with rolling the ball down the ramp, that opens up curves. And now we're going from linear calculus to curvature calculus, which is real calculus. So that's going to go from a duet to a trio. We're going to do the trio tomorrow, our first trio. And then that's where calculus comes in more handy later on. And I got to put a DT on that. And that just says that I'm finding the area over time. All right. And so it's whatever is that horizontal axis, that's D. It could be DX or DY or whatever the horizontal axis is in this case. And for the first 3 packets, at least, even the first 4 packets, the horizontal axis is time because it's kinematics. All right, so I'll give you a minute and I want you to do the other 2 if you haven't already. Do the other 2. And while you're doing those 2, I'm going to get my glasses because my eyes get all messed up. Okay, let me run down and get my glasses. You do the other 2. All right. Okay, I can't look. I have a big screen here and I can't look at that screen without these UV glasses. Start seeing cross-eyed. All right, so the next one, you show your boundary conditions. And for this is for the green one, the first green area. So I'm starting at 3. 3, green, hello. 3. And I'm going to, hello. I'm not starting at 3, I'm starting at 6. 6. Thicken that up a little bit. I'm going to 6, I'm going from 6 and I'm going to 16. So as long as you put seconds on one of those, I'm happy. And then now the function is 3, positive 3 meters per second. You got to put units in there. And I'm doing it over time. Okay. So these aren't that hard, but it gets you used to integral stuff, symbols, alphabet stuff. Finally, on the last one, the last one I wanted you to do, we're going from 16 to 24. It told us that. 16 to 24 seconds. This time we're down to -5 meters per second dt. So that's where the function is going to go. And the function here is constant. So it's almost a trivial case. But all right. So I'm assuming we can go on to the answer now. Unless there's a question. No questions popped up. So here we go. That's the final product. Nicely done. Let me blow this up a little bit. So there's the top graph. I'm using green for positives and blue for either negatives or 0. Okay, anybody see a mistake? You're also my checkers, and I want to find that mistake now because I don't want to record a mistake. Then I have to go back and do it all over again. I'm counting on you. You're a smart bunch here. And then there is that, and then there's my first interval. We already did these though, second and third. Okay. All right, that's the whole thing. Thumbs up to go on. Okay, good. Now we go on to this one. This one's new. And no one's asked a question about it yet because we haven't had much time to look at it. This is simply a relative. You'll find these in every physics book. It's a relative velocity problem where you have a common. It's called it is relativity. This is called Galilean relativity, not Einsteinian relativity. Okay, so we're not going close to the speed of light or anything. This is just basic algebra, really, just arithmetic. You're just adding these up. So here we have, put yourself on the Heartland Flyer, the train that goes down to Dallas, and say it's going at 28 miles an hour. So I'm going to make, just to keep, I don't like negatives so much, I'm going to make south positive. Okay. So I'm going to make that positive. I think I use this color scheme. Hold on. No, I didn't. I did the other one. Oh, well. I'm going to make, in this case, I'm going to make south positive. So it's a positive 28 miles an hour going down the track, heading south. Amtrak employee pushes a pastry cart full of donuts down the aisle towards the back. So this guy's going north, which I'm going to call, for this particular problem, I'm going to call south positive. You don't have to, but I'm going to call south positive. Okay, direction of motion is positive. That's also another overriding theme, which we'll get to later. So then this one's going, this is an arrow going the other way at 90 feet per minute. So there's weird units here too. It's not really gold standard or anything. It's just addition, but you have to take into account the units. A cockroach on the cart runs away from the employee at 32 inches per second. So if the employee, if he's pushing the cart, you got to think through this. So he's pushing the cart north, right? So that means because he's going the opposite direction that the train's going. So he's pushing the cart north. The cockroach is running. He's running. A cockroach on the cart runs away from the employee. Oh, I may have done that wrong when I was doing it. Cockroach runs away. No, that's still right. So well, let's see. If he's pushing the thing north, he's pushing donuts down the aisle toward the back of the train. Cockroach on the cart runs away from the employee. That means the cockroach, I think I did it wrong. Cockroach runs north then, right? North. If I make that north. If he's running away and the guy's pushing it north and the cockroach is running away from him, the cockroach is also running north. Right. Okay. So I think I did it wrong on the next page, but I'll fix it. At what speed in feet per second is the roach advancing towards Dallas? So even though the roach is running away from Dallas, he's running north, but the whole train they're in is going south. So he's still going south. Okay. So now let me go back and fix. Here's the answer, but I got to fix it. I just realized that should be green. So this should be green, which means this should be, let me erase my answer. That's wrong. Okay. This should be negative 2.7 feet per second. He's going away from the guy. So the cockroach is running north. Cockroach. I grew up, man. Oh my God. We didn't really have roaches when I was a kid, but when I worked in Texas, we had some of the biggest roaches. Texas has got some big roaches. All right. So I'll change my answer now, unless you guys, no one's saying anything. So I guess you guys aren't disagreeing with me. I got to end up in feet per second. So I went through and that should go positive now, or negative. I mean, north. Okay. So we have this big, huge blue arrow that is 41 feet per second. Huge, even huger than that. Huge. That's the train going south. The cart's being pushed up slowly, and then the roach is running away slowly. So those are the two north arrows, but they're really small. Okay, so I'm going to go with positive for this guy, negative and negative for these two guys. So you see what I'm doing? I mean, I include this problem because you see it all the time. It used to be in the program on one of the worksheets. I think I replaced it with something else, but it survived this practice problem. So whatever 41.1 minus 1.5 minus 2.7 is, it's way too much thinking this late at night for me. So I punch it in, and 41.1 minus 1.5 minus 2.7. That means that even though the roach is running north, he's really going south because of the train. 36.9, if my math is right. That seems about right. So he's going south at 36.9 feet per second. Okay. And that's called Galilean relativity. Problems, questions, comments? Nope. Okay. Thumbs up to move on. All right. Why is Finn? Finn must have his finger on the thumbs up. Let's get move on. I gotta be somewhere. Number 5. Now 5 is also a kind of a new problem. We've talked about, remember we talked about weighted averages, and we said that there's simple averages and there's weighted averages. So if you look at this first one, this first set, this is an example of simple average, because if I go blue for negative velocities and green for positive velocities, and the reason is, or somebody tell me, you can pipe in, or you, for a stamp, you get on the chat here and you tell me, why is this one on this side, why is this a simple average, simple, versus weighted? So what makes this a simple average? Oh, okay, people are jumping in there. Ryan was the first, though. He said they are all the same amount of time, and I got to give it to him. I'm going to give it to all three of you. Each of you get a stamp, because you're pretty much right at the same time. Okay, just time it takes to type, you know. And I agree. The reason they're all the same, it's a simple average, is they all occurred the same amount of time. So to find the average, I basically just have to add them up and divide by 4, I suppose. Did I do that? No, I don't think I divide by, I don't divide by 4. I don't divide by, yeah, I would. I'm at, because it's average, it's a simple average. So I have -2. I don't know if I did that in the answer. -2, and I have a positive 4 plus 4 minus 4 plus 6. So I add those up. I'm going to get 6 minus 4 is 2, 6, 4, right? It gives me 4. Negative 2 plus 4 is 2 minus 4. Yeah, 4. So 4, in other words, this is what the average is a red line that I can draw at 4 feet per second, but I can't draw it at 4 feet per second. I have to divide it by 4 because there's 4 velocities here, and I get 1 foot per second. So I think I made a mistake once again on the key. I needed to stop watching TV and working this at the same time. It's about Charles and Diana. So that's 1 foot per second. So your red line here is going to go right like that. So the red line is those 4, the two green lines, these 2 green lines, and the 2 blue lines added up. All 4 of them added up, and you get that red line. Okay. So the other one, though, you can't do that. I can't just take 2 minus 6, 2 plus negative 6 divided by 2. That'll give me the wrong answer. I have to, because I spent more time in the positive velocity than I did the negative velocity. Okay. So on this one, this is a little more complicated. This one you have to go through and find out where you were and do the old. We have to do the old. Let's find it like we were doing the first couple of problems on here. Stalactite, stalagmite. We have to go through the motions here. And so that is 2, 4, 7. So it's 2 times 7, 14. And this other one is 3 times negative 6 or negative 18. So when I add those up, I get negative 4 feet per second. But sorry. That isn't feet per second. Negative 4 feet, because I'm multiplying feet per second times seconds. So I get negative 4 feet. And then to find the overall velocity, I divide that by the total amount of time, which is 6, 7, 8, 9, 10 seconds. So the overall average is negative 0.4 feet per second. And that would be a red line then at negative 0.4. There we are, negative 0.4 right there. And this, when you look at it, it should look right. Is that red line a combination of that long green and the short blue? It looks, yeah, it looks good. It is on the negative side, but it's skewed a little bit towards that green because you spent so much time doing the green. Okay, I wasn't looking at the comments. I don't see any. No one's piped in to say anything. So my answer, I got to finish. I didn't quite finish. It looks like on simple average. Let me finish that real quick. Next page here. So we have 4 V bar is not just, it's 4 feet per second divided by 4, which is positive or negative? Yeah, positive, which is 1 foot per second. So that is the overall average there. Simple versus weighted. Okay, good. Keep going. Still got 15, 14 minutes here. If we go past 9:30, 9:30 was a suggestion. If we go to 9:40, now I got the Zoom thing. So we should, if I get cut off, it means I'm on the wrong account, but we should be good for as long as we want, but we'll try and finish up by 9:30. All right. Questions on this one? 5 and 6. You ready? We only got 2 more. You ready for 7? Thumbs up. You're a little slow that time, Finn. All right. So here's number 7. 7 is, in my opinion, by far the hardest problem on the test. I mean, you know, it's gold standard. So we have this formula. Now you're not going to actually, we seldom ever get this far to get to this formula unless I go off on some tangent one day in class. It's a big part of AP physics. So you'll have this in chapter 6, I think, in AP physics. Centripetal, remember we talked about centripetal. A sub C means centripetal, and it means center seeking. So if you're going in a circle, there's always a centripetal force that's keeping you going in that circle, whether it's a rope holding on to you or it's gravity or whatever it is, or it's your feet on the ground. There's some kind of center seeking force that's making you go in a circle, because you want to just keep going in a straight line, right? Newton's first law. So in this case, and there is this von Braun, I looked it up, it is still scheduled to be built by 2028. You could easily be in this hotel and you'll say, I did a physics problem on that once. So by 2028, in 6 short years, you could be up in this hotel, spend the night. Okay, so in that hotel, they'll have artificial gravity, so they need to have centripetal acceleration, which will be their version of sort of G, pointing inward. So all through this station, at any given time, you're going to have this inward force. And it's basically on the wall acting on you. Okay. And that's that A sub C. Okay, and that's the formula. It's your velocity you're moving at squared, your tangential velocity squared, divided by the radius. And it's not just something made up. We actually derive that in AP physics. You have to show the steps to derive this. It's about a 6-step derivation. Okay, use the formula for centripetal acceleration and some Black equation substitution. So we remember, just to keep this in mind, we have the V is equal to omega R. That's the mini bridge. And that's usually the one we use. We seldom ever use the big bridge. The big bridge is delta S equals omega RT. All right. All right, and some Black equation substitution. Determine omega in radians per second. Okay, so first off, I should be writing these in here. So we say, okay, AC equals, let's blow this up a little bit. AC equals V squared over R. Now, if you're watching the recording of this, I highly suggest you hit pause and you try and do this on your own. Okay, for your own good. Copying something down is helping nobody. All right, so pause it. Now you're back from pause, you've tried it. We're trying to come up with an equation that looks like for omega. So I come over here and I'm going to substitute this. I know that V equals omega R. And keep changing size. This didn't used to be this way on Explain Everything. It used to not do this, and they think they're clever and they're just making it more difficult. All right, so V is equal to omega R. I'm going to do a little substitution, right? I can substitute omega R in for V. So I have AC equals omega R squared over R. You can stop me anytime, ask a question. So that squared goes to both. So that equals omega squared R squared over R. Okay, that shouldn't be too traumatizing for you guys. Well, I can get rid of an R, I can cancel one of the R's. And so basically AC Tatum came in at lunch and her and I worked this one. I told her I worked it wrong. Oh, okay, yeah, I did. Okay. Because we're fine. No, I did. Because Rafael came in and said, I think you got something flipped. I know why, because I'm thinking AC is omega squared times R, which is fine, but we're not solving for that. We're solving for omega. Okay. So then if I take this equation, that scared me for a second. I take this equation and I got omega squared there. I got AC there. I got R there. So if to fit omega, I divide both sides by R, right? So omega equals, find some room here. Let's carve out some room here. So omega, I don't want to run through this too fast. So therefore, omega equals AC over R. Omega squared equals AC over R, and then omega equals the square root of AC over R. So over here, omega equals the square root of AC over R. I don't think, I wouldn't spring this on you on a test, right? I mean, not now, maybe second semester, but I wouldn't spring this on you because I don't, it's hard enough on a test, all the stress going on, cortisol's running through your brain. It's hard to sit there and logically, you're in a time, So it'd probably be something, I'm not saying this wouldn't be on the test on Friday. I haven't written the test yet, but this could be on there because now we're seeing it. Now we're doing it. But I wouldn't like surprise you totally. That'd be, at least not first semester. Okay, so now we come down to work this, and we are going to take, I don't want to forget. So I'm going to scroot everything before I forget. So big old scroot. And then I put AC there. I put 1 over R. Okay. And now I got to plug in my givens. And it said that the AC is like the gravity. So AC would be 105 yards. Now it's 105 yards per minute per second. But remember, you can write that as 105 yards per minute dot seconds. Hey, by the way, if I'm going too fast, whatever, you may have already seen this. You guys are the, you're the cream of the crop here. So you may have already seen this, but there is a help video on this one. In fact, I put it on, it's on Facebook, but I put it on the group me as well, the link. And then 1 over R. R is 190 meters, 1 over 190 meters. Okay. From then on, it's just some conversions. I'm trying to end up in what's it asking for? What is it asking for? Required. What formula for? Here's what I found. What? Shut up, Siri. Radians per second. So I'm trying to end up in inverse seconds because we know that radians doesn't have a unit. So I'm trying to end up with seconds on bottom. So inside the radical, I gotta have seconds squared, right? Because we did this today in class because I want to have seconds in my answer. So I want to end up with seconds squared. I'm going to circle that guy. I already got one of them. I got to kill yards, kill meters, kill minutes, and replace it with seconds squared. Hey, if I see it right off the bat, I'm going to go minute over 60 seconds. Haha, it's a puzzle. I circle that. I get the second I want on bottom. I kill the minutes all in one fell swoop. Now I got to get yards out of there. Here's some conversions here. It looks like a yard has to go on bottom to kill it. 3 feet. Can kill the yards. I got to kill feet. Oh, meters and feet. So once we got through the givens, this became a pretty easy problem. 0.305 meters in a foot. And now kill. Double slash says I'm through. I know there's a double slash over there. And then you punch in your numbers. Oh, thank you. Thank you for that, Finn. Finn was the first to say it, though. 190 is the diameter. I got caught. I hate that. If I had seen this on a test, and you said 190, you didn't say what would it be? 90, what is it? 190, 95. So if you said 190, not 95, I'd probably take off a couple of points is all. That's a cheap shot. Cheap shot by moi. Yeah, look at that. Oldest trick in the book. And I fell for it. Okay, I hope I didn't fall for it in the key. All right, so that's what I got. Let's see. Yeah, I did not fall for it in the key. Okay. Here's the official key. I get 0.13 radians per second. How fast is that? This is, I mean, I'm trying to be as accurate, I mean, as what I'm thinking. I probably looked it up. Yeah, no, I looked it up. The gateway is what it's called. It's going to have a diameter of 190, about 2 football fields. So that thing is moving at 0.13 radians per second. How fast is that? How fast does that look? 0.13. How fast does second hand go again? It takes it 60 seconds. It goes 2 pi radians in 60 seconds. So I should have left it. You know what? Oh, well, it didn't rate. There's no pi's in there anyway. So 6.28 divided by 60. So a second hand moves. Okay, so it's moving a little, it'll rotate a little faster. A second hand's about 0.10. This is 0.13. So that space hotel that you may end up spending the night in will be rotating at about the same rate that a second hand goes around on an analog watch. Okay, a little bit slow, a little bit faster than that. Okay. So you can tell this to your, your fiance, not your fiance, sorry, your bride or your groom on your honeymoon, and they'll think you're a big nerd. All right, so now we go to, hold on a minute. Schwargo asked, is writing S? Yes. I said radians per second, but I'll certainly, of course, I'll take inverse seconds. Radians is just to kind of to dress it up a little bit, make it more palatable for the layman to see it and not freak out. Radians per second. Notice that I didn't call it here on the key. I didn't call it AC. I called it G, but it's like artificial G. I don't know. I don't like that I did that, but I'm calling it. It mimics the lunar gravity. Okay, so that's why I went and called it G. Okay. So if that mimics, huh. So you're going to be, if it goes at that speed, you're going to feel like you're on the moon, like 1/6 the Earth's gravity. So if they wanted to make you feel like you're on Earth for a day, they could just speed it up. But that'd be kind of weird. It'd be throwing up. Okay. Finally, we get to the last one. We're at 9:30 here. This one is a finger walking. Okay, fingers are walking. Fingers, looks like your fingers start here at the 30 centimeter mark. You're gonna so you do this kind of like you've already done. It's a little bit of a different take on the same issue. We have negative, we have stalactites, which represent our fingers going backwards. And then we have stalagmites, which represents our fingers going forwards. Okay. And so this is really, it's not that new of a problem. Don't freak out on this one. It's the same kind of problem we've had. Only now we have to find the areas. And when I find the areas, then that tells me where to go. So when I find, like, for instance, I find this area here, I get, I think that's -28, right? -28 centimeters. Negative, once again, pause this if you're watching the recording. -28 centimeters. So I start, because it is 7 times 4 times -4. So that means I start here at 0 at 30, and because it told me to start there. and I walk backwards. I do my fingers, kind of the moonwalk back to the 2 centimeter mark. So I start off going backwards. That's why these little lines are here to give you a little path to the 2 centimeter mark. Okay. At that point, it looks like I turn around. And now my fingers, this guy is 10 times 5 or 50. This is 50 centimeters. So then I turn around and go 50 centimeters the other way, and that's going to put me at 52. You don't have to use a ruler here. I'll take a little shaking hand. 52. Then I turn around and go back real slow at 2 centimeters a second. This is supposed to be centimeters per second. Got cut off there. So I go backwards 2 centimeters a second for 2 seconds. So 4, I go back to 48. My fingers now go back to 48. Okay. Then I go back a lot faster at 8 centimeters a second. I do that for 5 seconds. So I drop back to 40. So I end up at 8. And finish. I finish right there. So that's showing my positive negative path. Questions before we wrap it up with this question 8C. What's the velocity and position of your finger at 16 seconds after you start? Well, here I'm at the 16-second mark, puts me right there. Okay, so my velocity is obviously -8 centimeters per second because that's where I'm at. And then my position is an accumulation of position. So let's see, I was at 48 here, and then I'm adding on 8, 16 less, so 48 minus 16, I'm at 32 centimeter position. So at the 16-second mark, I am right here along my path. That's where I'd be at the 16-second mark. Okay. And yeah, the key is a little nicer, but let me add these in. That's -8 centimeters per second, and that's a 32 centimeter mark. Okay, questions? Any questions on this practice problem? This represents about half the test on Friday. Questions? Going once. Okay, what I'm going to do, I'm going to stop the recording, and then you don't have to leave. Let me stop the recording. Stop.